Electric dipole. Electric dipole is a system of two equal and opposite charges separated by a distance. This figure shows the structure of the electric dipole. The electric dipole consists of a minus q charge and a plus q charge separated by a distance 2a. In nature, there are many examples for electric dipole. For example, sodium chloride molecule is an electric dipole. We know sodium chloride is formed by transferring one electron from sodium atom to the chlorine atom. Hence, the sodium becomes a positively charged ion and chlorine becomes a negatively charged ion. There is a bond distance between sodium and chlorine. It is bonded by ionic bond. Therefore, sodium chloride molecule is an example of an electric dipole. Other examples are all polar molecules, just like hydrogen chloride, water, etc. These are the examples of electric dipole. I told you, electric dipole is acting as a system or as a single unit. Therefore, to describe the strength of the electric dipole, we have a quantity called electric dipole moment P. What is electric dipole moment? It is the product of one of the charges in the dipole, and the distance between the charges. You can see here, minus q and plus q are the charges in the dipole. So to define the electric dipole moment P, you can take one of the charge q and the distance 2a. The product of q and 2a is called electric dipole moment. Therefore, P is equal to q into 2a. Electric dipole moment is a vector quantity. It is not scalar, it is a vector quantity. That means it is having a direction. What is the direction of electric dipole moment? Electric dipole moment is directed from minus q to plus q. Therefore, the electric dipole moment is directed from minus q to plus q. This is the direction of the electric dipole moment. So far we have discussed what do you mean by an electric dipole and how the strength of the electric dipole is measured. This concept, because here the electric dipole is acting as a single unit, it produces an electric field around it, and also when it is placed in another electric field, it interacts with the second electric field. To analyze this problem, we have the concept of electric dipole moment. That is the significance of electric dipole moment. Electric dipole moment is defined as P is equal to Q into 2A. Then what is the unit of electric dipole moment? It is a new quantity. You need a unit to measure electric dipole moment. You can understand the unit of electric dipole moment from this formula. The unit of Q is Coulomb and the unit of distance is meter. Therefore, Coulomb meter is the unit of electric dipole moment. Once again, electric dipole moment is a vector quantity. Its magnitude is given by P is equal to Q into 2A and the unit is given by Coulomb meter. Now, we are going to discuss about the electric field produced by the electric dipole. Just like the point charges, the electric dipole also produces an electric field around it. And each and every point of that space will have intensity of the electric field. So, now we are discussing about the intensity of the electric field due to the dipole. I told you the space around the electric dipole is an electric field. You can find out the intensity of the electric field at any point. I think you are remembering the definition of the intensity of electric field. Intensity of the electric field at a point is the force acting on a unit positive charge placed at that point. Here we are finding out the intensity of the electric field in two directions. One is a direction parallel to the length and passing through the center. This direction is called, or this line is called, axial line of the dipole. Therefore, we can find out a formula for the intensity of the electric field at any point on the axial line. Another one is the intensity of the electric field at any point on the equatorial line. What do you mean by equatorial line? Equatorial line is a line passing through the center of the dipole and perpendicular to its length. Therefore, now we are going to calculate the intensity of the electric field at any point in these two directions. First, we can do the derivation for the intensity of the electric field at any point on the axial line. For that, we can take a point P at a distance x from the center of the dipole. Therefore, P is a point at a distance x from the center of the dipole. Let E be the intensity of the electric field. Let E be the intensity of the intensity means what? Once you place an 1 Coulomb of positive charge here, this dipole will exert a force on it. And that is called the intensity of the electric field. We are imagining it as capital E. To find out E, we can use Coulomb's law and the principle of superposition. For this purpose, you can consider the charges in the dipole separately. First, we are finding out the intensity of the electric field at P due to plus Q. At that time, you can forget about minus Q. First, you can find out the intensity of the electric field at P due to plus Q charge. Let it be E1. Therefore, intensity of the electric field at P due to plus Q alone. Plus Q is equal to, we have the formula for the intensity of the electric field as, due to a point charge, as 1 by 4 pi epsilon 0 into Q by R square. Therefore, E1 is equal to, what is E1? E1 is the intensity of the electric field at P produced by plus Q alone. That E1 is equal to 1 by 4 pi epsilon 0 into Q means Q only, the charge Q. R is the distance between the charge and the point. What is the distance here? OP is X, and this distance is the half length of the dipole, it is A. Therefore, this length is X minus A. In short, the distance between plus Q and P is X minus A. Therefore, E1 is equal to 1 by 4 pi epsilon 0 into Q divided by X minus A the whole square. It is a vector quantity. What is the direction of E1? It is along OP. It is along OP. It is along OP. Why? Because once you place an 1 Coulomb of positive charge here, this plus Q will repel and the force is in this direction. Therefore, E1 is directed from O to P. Therefore, the value of E1 is 1 by 4 pi epsilon 0 into Q by X minus A the whole square along OP. I told you to find out the intensity of the electric field at P, we are using the principle of superposition. As a first step, we have calculated the intensity of the electric field at P due to plus Q. What is the next step? Next, you have to find out the intensity of the electric field produced by minus Q at P. The same formula can be used. The intensity of the electric field produced by minus Q at P is 1 by 4 pi epsilon 0 into Q by R square. What is the value of R? R is the distance between minus Q and P. Here, this R is equal to, in this case, this R is equal to, what is the distance? P to this distance. This is X plus A. Okay. Next, we can find out the intensity of the electric field produced by minus Q at P. Okay. That is E2. E2 is equal to the intensity of the electric field produced by minus Q at P. It is E2. E2 is equal to 1 by 4 pi epsilon 0 into Q by R square. R is X plus A. R is X plus A, the whole square. And what is its direction? Once you place an 1 Coulomb positive charge here, you know minus Q will attract it. Therefore, what is the direction of the intensity of the electric field produced by minus Q at P? It is along PO. It is along PO. Okay. Then, how to find out the intensity of the electric field at P due to the entire dipole? That is how to find out the E here. We can use the principle of superposition. By principle of superposition, E is equal to E1 plus E2. Here, once you are trying to add, these quantities are in opposite direction. One is along OP, the other is along PO. To make the addition simple, I am doing a mathematical operation here. E2 is equal to, I am putting a minus sign, minus 1 by 4 pi epsilon 0 into Q by X plus A the whole square along OP. The direction instead, the PO, now I have changed it to OP. This effect is nullified by this negative sign. Therefore, both of them are equal. That means 1 by 4 pi epsilon 0 into Q by X plus A or the whole square along PO is exactly equal to minus 1 by 4 pi epsilon 0 into Q by X plus A the whole square along OP. I can make this point clear because a vector vector A along north direction is equal to minus vector A along south. It can be written as like this. This concept is used here. Therefore, both of them are exactly equal. There is no change in the value. Now we are in a position to find out the intensity of the electric field at P. The intensity of the electric field at P is equal to E1 plus E2. Okay. Then E is equal to, you can substitute the values, 1 by 4 pi epsilon 0 into Q by X minus A the whole square plus minus 1 by 4 pi epsilon 0 into Q by X plus A the whole square. What is the direction? Along OP. So, to simplify this expression, you can take the common factors outside. Q by 4 pi epsilon 0 is the common factor into 1 by X plus A the whole square minus, plus into minus is minus, 1 by X minus A the whole square, 1 by X minus A the whole square into, plus into minus is minus, 1 by X plus A the whole square along OP. Now you can take the LCM. E is equal to Q by 4 pi epsilon 0 into X minus A the whole square into X plus A the whole square in the denominator. What is the numerator? It is X plus A the whole square minus X minus A the whole square, and the direction is along OP. So once you take the LCM, X plus A the whole square minus X minus A the whole square divided by X minus A the whole square into X plus A the whole square. Here we can use the identity. We have the identity like this. A plus B the whole square minus A minus B the whole square is equal to 4AB. This identity we are using here. Therefore, you are getting the expression is equal to Q into Q by 4 pi epsilon 0 into 4AB, 4AXA, 4XA, 4AB is the formula used. This can be written as X minus A into X plus A the whole square. Therefore, now we are coming to the expression. The intensity of the electric field at P is given by Q by 4 pi epsilon 0 into 4XA divided by X minus A into X plus A the whole square. X minus A into X plus A is X square minus A square. Therefore, it is equal to Q by 4 pi epsilon 0 into 4XA divided by X square minus A square the whole square. Okay. Therefore, the intensity of the electric field at P is given by E is equal to Q by 4 pi epsilon 0 into 4XA divided by X square minus A square along OP. Now, we are doing a mathematical adjustment without changing the value of E is equal to 1 by 4 pi epsilon 0 into 2 into Q into 2A X divided by X square minus A square the whole square along OP is the direction. Here you can see that there is no change in the values. Q is here. The 4 is written as it is in the splitted form. Q4 is written as 2 into 2 and A is there. Therefore, it is Q into 4XA only. Okay. Why you are writing like this? This is to introduce the electric dipole moment. We have the formula P is equal to electric dipole moment P is equal to Q into 2A. So, you can replace this Q into 2A with the P. Therefore, the expression becomes E is equal to 1 by 4 pi epsilon 0 into 2px divided by A square minus A square the whole square. Here you need not write the direction along OP because what is the direction of P? We know it is directed from minus Q to plus P, or it is directed from O to P. Since P is a vector, you are getting the expression E is equal to 1 by 4 pi epsilon 0 into 2px divided by X square minus A square the whole square. This is the formula we have derived. Using the formula, you can find out the intensity of the electric field at any point on the axial line. P is the dipole moment of the dipole. X is the distance between the point and the center. Usually, the value of X is very, very greater than A because we can take the example of sodium chloride or hydrogen chloride molecule. The bond distance is extremely small. Therefore, the distance from the point to the center is usually large. Therefore, A square can be neglected. You can take the value as 0. Therefore, how the expression changes? E is equal to 1 by 4 pi epsilon 0 into 2px divided by this A square is 0. Therefore, X square raised to 2, that is X raised to 4. You can cancel this 4 and X and you are getting the final expression as E is equal to 1 by 4 pi epsilon 0 into 2p by X cube. Okay. Therefore, this is the formula for the intensity of the electric field at any point on the axial line. Any point on the axial line. P is the dipole moment and X is the distance between the point and the center. You can see that the intensity is inversely proportional to the cube of the distance. In the case of the point charge, it is inversely proportional to the square of the distance. That is the difference. And the direction of E is the same as the direction of P, means it is directed from minus Q to plus Q. Okay. But therefore, we have derived the formula for the intensity of the electric field at any point on the axial line of the dipole. Next is the formula for the intensity of the electric field at any point on the equatorial line. We will do it later. We can stop here. Thank you.